Alright, this lesson is about graphing square root functions and cube root functions. This was a quiz, but it will be a good review for you. Square root. You see a square root, think about the numbers that you can take a square root of easily without getting decimals. These numbers are 0, 1, 4, 9, and 16, but that's going to be off the grid. It's too big. So these are the numbers that we will always start with. Now, does this function have an a value? What am I talking about? I'm talking about a number in front of the function, like this. Because the general model is x minus h plus k with an a in front of it. Okay, this is the general model. So, does it have an a value? Yes, it does. This negative sign, think of it as a negative 1. When there is an a value, what you want to do is make a third column on this table. Okay, we're going to need a third column. So, always look, see if there's an a value. If there is one, make a third column. Okay, so this will be the a times y column. Anyway, the y values. All right. To get this column, we're just doing the main function. Okay, without the a value, without the h and the k, just the square root of x. So we're going to get 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Very good. Fantastic. Now, we apply the a value. The a value is negative 1. So we're going to take negative 1 and we're going to multiply it by all these y values. So we will still have 0. Negative 1 times 1, of course, is negative 1, negative 2, and negative 3. Once you have the third column, you disregard the second column. We're not going to use that anymore. Okay? So this is what we're going to graph next. But graph it lightly, graph it gently. This will not be the final answer because we've done the negative 1 and the square root, but we haven't done the shifting. All right? We haven't done the plus 6, plus 5 business. So do not connect these dots. So we have 0, 0, and we have 1, negative 1. We have 4, negative 2. And we have 9, negative 3. Okay, so you can see the shape of the function happening. All right, you can see that has been a reflection over the x-axis so far. Now we're going to go ahead and do the rest of the transformation. Now, speaking of transformations, let's go ahead and make our list now. Okay, here are the transformations. Well, the negative 1 that we already did, that is a reflection over the x-axis. You know what? Maybe I'll type this. Okay, so we have reflection over the x-axis. Okay? Now, this plus 6, whatever you have happening on the inside of the function is a left or right situation. So adding 6 is actually going to be a translation left 6. Okay, it's always the opposite of what you would think inside there. So plus 6 is to the left. So left 6. Now, anything happening outside the function, okay, is something that's happening vertically. So this plus 5 is a vertical shift, up 5. Out here it happens like you would normally think. Positive would be up. So up 5. And that's it for the transformations. Just those three. Reflection of the x-axis, left 6, up 5. Okay, great. So that's what we're going to do now. Left 6, up 5. So I'm going to take each one of these dots and move them left 6 and up 5. Okay, so this sort of starting point here is going to move here. Now the rest of these are going to stay in the same shape, just shifted left 6 up 5. So it's easy for me to see that this is what's happening. Okay, just the whole thing is moved left 6 up 5. So this is going to give me the function. Now remember, this is a starting point, so I'm not going to put an arrow through. Whoa, I'm not going to put an arrow through this or anything. I'm just going to draw. So starting here, it's going to curve like this. And then it'll go on like that. So let's talk domain and range. Domain is left to right. X values go from -6 to infinity. So that's the domain. It touches -6, so we'll make that a square bracket to include the -6. The range, that's y values. The y values, well, look how far down this goes. Now, it goes down, down, down forever. So you have to start with negative infinity. So it's going to be negative infinity to 5. Okay, the negative infinity must come first. So it's always bottom to top. Negative infinity to 5. And again, the 5 gets a bracket because it reaches 5. It touches 5. It's right there. Okay, and that's it for problem number 1. All right, problem number 2. Does this have an a value? Kabam! Yes, it does. Again, when there's an a value, go ahead and make a third column. All right, we're going to need the third column to accommodate the application of the a value. Make it happen. Respect. Okay, and here's where we will do a times the y. So anyway, we're talking cube root now, people. So when we do this, find the y values, we're going to find it by doing the cube root of the x values. So we need values that we can easily do cube root of. 0 still works great. But we're not going to use 4 anymore. That'd be a decimal for sure. But the cube root of 1 is still going to be good. And then we got the cube root of 8. These are the numbers that we use. For cube root, though, you can do negative numbers. So we can also do -1 and -8. So these are the 5 values that we always use when we're starting to graph a cube root function. And let's do the cube root for the y value. So the cube root of -8 is -2. Cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1, 1. Cube root of 8 is 2. Now here comes the third column. Alright, the a value is 3. So that means we're going to take 3 and multiply it times all these y values. Okay, so that's going to give us -6, -3, 0, 3, and 6. Again, once we have the third column, we disregard the second column. We're not going to use that anymore. Okay, so again, let's graph this new table. But this is not the final answer because we haven't done the +2 or the -1 yet. So we will graph it as a skeleton. We will not connect the points. So -8, -6. That's where it all begins. So -8, -6. Okay, -1, -3. All right, 0, 0, 1, 3, and 8, 6. Okay, so you can see the wave that's happening here, but don't connect the dots yet. Now, let's talk about transformations. Okay, we will have 3 transformations, and I'm going to type them in again. Let's start with that a value. Okay, that a value of 3. Now, putting a 3 in front of a function like that, this is a vertical stretch. Vertical stretch by a factor of 3. Okay, that's one transformation. Now, as we discussed in problem number 1, in here is a left-right motion. So this plus 2 is a shift to the left 2. It's the opposite of what you normally think. So this will be left 2 and down 1. Alright, left 2, down 1. Alright, those are the transformations. So let's go ahead and do the transformation. Well, we've done the vertical stretch. That's what these pink numbers are. But now let's do the left 2, down 1. Okay, so we will take each one of these points and move them left 2 and down 1. So left 2, down 1, left 2, down 1, left 2, down 1, left 2, down 1, and left 2, down 1. So all that's left is to draw this sort of wave through the points like that. Kabam! So this is what it looks like. So that's the answer. Let's not forget the domain and range. Domain and range will be easy for a graph like this because domain is x values. It goes to the left forever. So that's going to be negative infinity. It goes right forever. So negative infinity to positive infinity. Range is going to be the same thing. It goes down forever and up forever. So that's also negative infinity to positive infinity. So that's going to be the same for all cube root functions. Alright, so domain and range are both negative infinity to positive infinity. And that's it for number 2. Number 3, will we need a third column this time? Is there an a value? Well, other than 1, no. So we will not need a third column. So this is square root, so use the proper numbers. So we will use 0, 1, 4, and 9. And we will take the square root. Okay, and that's how we'll find this column. So that's going to be 0, 1, 2, and 3. This is not the final answer, so we will not connect these dots. This is a skeleton. So this is the parent function. So 0, 0, 1, 4, 2, and 9, 3. Okay, do not connect those dots. So now we will do the shifting for the final graph. But let's write it down. So the transformations are, they're only the 2. Because of the minus 1 here, that's going to be right 1. Okay, the plus 2 is going to be up 2. Right 1 and up 2. So that's what we're going to do. We're going to shift all of these points right 1 and up 2. So this will be our new starting point, and the other points will go like this. Okay, so there you go. So now we just draw the curve through that, and we're golden. So this is what your graph should look like. And the domain. The domain is the x values, which go from 1 to infinity. So that's the domain is 1 to infinity. The range is the y values. Y values go from 2 to infinity. So 2 to infinity. And that is it for number 3. Alright, for number 4, we're supposed to write the equation of a radical that has domain 6 to infinity and range 9 to infinity. Well, right away, is this going to be some sort of a square root function, or is it going to be a cube root function? Those are the only 2 radicals that we've worked with so far. Well, you know it's not going to be a cube root function because the domain and range would both be negative infinity to positive infinity if that was the case. So, you know that we're dealing with some type of a square root function. Okay, so if the domain goes from 6 to infinity, Alright, that means that the graph has to start at 6 and go to the right. So if we have like, let me keep it like this. So 6 to infinity. So I have 1, 2, 3, 4, 5, 6. So it has to start here and go to the right. So you know, it could be somewhere over here. You know, something like this type of thing is what we're dealing with. Okay. But it also has to have a range of 9 to infinity. So as far as the y values go, 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever. So it has to start here. It has to start at 6 and go to the right, and has to start at 9 and go up. So we're picturing this type of a deal. Okay, this function right here. And you know, so this right here is the point 6, comma 9 is the starting point. So that's important because you know, the parent function would have started off at 0, comma 0 and done its thing. So if it has moved from 0, 0 to 6, 9, that means it has shifted to the right 6 and up 9. So you have to ask yourself, what would you have to do to a square root function to make it shift right 6 and up 9? Well, as we've seen on the previous problems, okay, so we'll say f of x equals the stuff that happens on the inside of the radical is the shifting left or right. So if I want to go right 6, now everything in here is the opposite of what you would normally think. So we need x minus 6 in there, and that will take you to the right 6. Now if I want to go up 9, I need to put a plus 9 on the end of it, like that. Okay, so there you go. That's it. Alright, so number 5. Use the description to write the square root function g. Okay, the parent function is, well, they already said square root function, so we kind of already knew that. Anyway, we want it to be reflected across the y-axis and translated 3 units down. So they said call it function g, so fine, we'll call it function g, so g of x. We want it reflected across the y-axis, so we have learned that if you want a reflection across the y-axis, you put a negative sign in front of the x inside the radical. So there's your reflection across the y-axis. Now we want it to be 3 units down. That happens if I put a minus 3 out here on the end. Is that it? Alright, is this really that easy? Yeah, square root function, reflect across the y-axis, 3 units down. That's it. That's all there is to number 5. Okay, 2-second problem. Alright, watch out for this. You will get it wrong. If you get sloppy with your symbol and you put your minus 3, if it looks like the minus 3 is underneath the radical, that's a no-go. Okay, that would be, well, technically, you know, I started to say that would be left 3, but that was a lie. Because really, to read it, you have to factor out the negative 1, so that would leave x plus 3, which would actually be to the left 3. Anyway, don't want to confuse you. The point is, make sure you leave your minus 3 well out from under the radical. And that's it. That's it for this lesson. That's it for this quiz. I hope it was helpful, and I will see you on the next video.